Today we're going to be doing an experiment at home based on Boyle's law and Charles' law. Boyle's law states that the pressure and volume of an ideal gas is inversely proportional so long as the temperature and mass remain constant. That simply means as the volume increases, the pressure decreases, and as the volume decreases, the pressure increases. For this experiment, you're going to need the largest syringe you could find. This one is a 16 ml syringe, a balloon, or if you have smaller ones where you use like the water balloons, that would be great, and a pair of scissors and some elastics. Because I don't have a water balloon, I'll be using a regular size balloon, which is a bit too big to go into my syringe. So what I'm gonna do is just cut off this whole thing where you would tie the balloon normally. I would cut it right there. Got it. And then I would just tie an elastic around whichever end I want to start off with. You want to get it so it's tight because you don't want any air loss. And then I'm going to just simply blow into this end. Keeping in mind the size of the balloon because you want it to fit into the syringe. I think this volume is good enough for me. So I'm going to tie this end with an elastic as well. And this is what I have. Because I want it to be rounder, I'm going to take the two ends and bring them together and then tie this end with an elastic as well. If you want to cut off any excess balloon, you can do that, keeping in mind where you're going to cut off because you don't want it to be too short at the outer part of the elastic, causing it to let go. So now we're going to take our syringe and drop the balloon inside of the syringe, then placing the plunger inside of it. You're going to then take your index finger and put it over the opening of the syringe, keeping the air particle mass constant. And just watch how the volume of the balloon decreases. You're going to then remove your hand to release the pressure. Now we're going to put the plunger as close to the bottom as possible without touching the balloon. You put back the pressure. So I'm just going to put it here now. And then I'm going to pull up on the plunger and watch how the volume increases. Yeah. Boyle's law states that the absolute pressure exerted by an ideal gas is inversely proportional to the volume it occupies if the temperature and mass, or the amount of gas, remain constant in the enclosed system. An ideal gas is theoretically random moving non-reacting particles. The ideal gases obeys the laws of ideal gases such as Boyle's law, Charles' law, and the Gay-Lussac's law. Some examples of ideal gases are oxygen, hydrogen, and carbon dioxide. In this experiment, when we placed our finger over the mouth of the syringe, this kept all the gas particles inside, which meant that the pressure was constant. In this experiment, the syringe and the volume has a certain amount of gas particles inside. By placing our finger over the opening of the syringe allows us to keep the mass of the balloon and the syringe at constant, which allows us to manipulate the volume and pressure inside of the syringe. This creates a closed system for us. When we push down on the plunger, the air pressure inside of that increases, decreasing the volume, pushing down all the air molecules onto the balloon, which makes them more compact, which will decrease the volume of the balloon. When we release our fingers from the opening of the syringe, it releases the pressure and the volume of the balloon goes back to its original shape. When we pulled up on the plunger, this was decreasing the pressure and increasing the volume, which means that the gas particles had more volume inside of the balloon, which caused it to pull up, causing the balloon to increase in size. When we released our hand from the opening of the syringe, the volume of the balloon then turns back to its original shape. So for the Charles' Law experiment, we're going to need a bag of balloons, preferably assorted ones so that you could differentiate which was which, a measuring tape, a bucket or bowl of cold water, ice cold water. In my case, I have a pot of cold water or ice water because I couldn't find a bowl, and a hair blower to heat up the other balloon. The thing you're gonna do is inflate both balloons at exactly the same diameter. So I'm gonna show you guys that my balloons are actually 14 inches. I'm gonna measure the yellow one so that you'd know that it is indeed 14 inches. Yep, 14 inches. So now I'm gonna take the blue balloon and I'm gonna dunk it and just swirl it in this water for about 2 minutes. You wanna set a timer. It's ice water, by the way. You wanna set a timer so you could monitor this. What I do now, I'm just gonna remove the balloon and retake the diameter. Take it out. As you can see, I got my diameter down to about 13. So this balloon shrunk. So now I'm going to heat up the other balloon for 2 minutes and see what. So now I'm going to take the yellow balloon and I'm going to heat it up with this hair blower for about 2 minutes and see what happens. Let's go. Okay, so now we're gonna retake the diameter of this balloon to see what happened. Diameter like increased by a half an inch, to be honest. It increased by a half an inch. And that's what happened when we heated a balloon, it expanded. And when we cooled a balloon, it shrunk. You may be wondering, what is Charles' Law? Charles' Law was named after Jacques Charles, which states that the volume and temperature are directly proportional. The balloon that was heated, the gas particles banged against the side of the balloon. By expanding it, this kept the pressure constant. The faster the gas particles move, the more it hits on the sides of the balloon, causing it to expand. On the other hand, where the balloon was cooled down, the gas particles in that balloon decreased when the temperature decreased, which caused the gas particles to slow down and have less impact on the sides of the balloon, which made it shrunk.